Hello folks, we have here a standard 52 card deck. No jokers. We don't include the jokers unless it specifically says to. So you shouldn't really need to ask. It'll say to if you don't hear it. Standard 52 card deck, then no jokers. But for those of you who are not familiar with um, a deck of cards, this right here are called spades. These are obviously diamonds. These are hearts. And these are what we call, no, I said that wrong. These are spades. And these, sorry, I looked at the king really quick and couldn't quite tell. These are what we call clubs. Well, let's do that, right? C-L-U-B-S, I can spell. Okay, so that's what a 52 card deck consists of. And you can see there's no one. Usually aces will represent ones, or sometimes, depending on the game you're playing, it could represent 11. But this is where it goes. Ace, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then you have your face cards, obviously, so that face is on them. Jack, Queen, King. So there is your 52 card deck. So we have similar, we've seen questions like this before. So I've got 3 events. This should be C. C. Event A is choosing an ace. Event B is choosing a king. Event C is choosing a club. So here we've got 2 specific cards, and here you've got a whole suit. So if I'm over here and I'm thinking, all right, well, finding the probability of an A or a B. A is an ace or a king. That's going to give me like, here are all of my aces right here. And here are all of my kings right here. And so I can see that I don't have any aces that are also kings. So these are mutually exclusive. So here, what I do is I have my text. I'm going to make this red. And so I end up with equals, and I have 4 out of 52 cards that are aces, plus another 4 out of 52 cards that are kings, leaves me with 8 out of 52 cards that are either aces or kings. The other issue that we come up with is here with the clubs. Now the clubs that we've got here is this group way up here. Let me make the right color here. Sorry. Is this set way up here. So if I want either an ace or a club, that gets a little bit different in that what I have now is that 4 out of 52. But here I've got 13 cards that are clubs. All right. But I've got this little guy right here that is both. So they are not mutually exclusive. So here's where I have to subtract that ace of clubs. I included it here. I included it here. That's twice. So I need to take it out. So I only include it once. And that's going to give me 16. 4 plus 13 is 17. Minus 1 is 16 out of 52. So, oops, no, I don't need a J in there. So I get 16 out of 52 for that one. Make this a little bit longer. There we go. Same idea here. I've got 4 kings. I've got 13 clubs, but I've got the king of clubs, which is counted twice. So I end up with this very same thing as this one. So I've got the same idea. 4 out of 52 kings, 13 out of 52 clubs, minus the 1 that they share. So there again is our addition rule that we want to try to make sure that we take care of. Is this going to give me something else? Come on, folks. Copy. Paste. There we go. We got it again. Now, what if I said something like this? Suppose you got a heart So this is that conditional probability. Suppose you get a heart, and with all of those hearts, what's the probability it's also a face card? So when I'm looking at that now, I want to take a look and say, well, all right, if that's going to be the case, then, whoops, let's go back here. What I want to take a look at is all those hearts, which is this right here. Hearts, make sure I got the right ones. Hearts. And these are the three that are face cards. So because I know I have a heart, I don't care about any of this. And I don't care about these. So I'm only looking at my hearts. So there's 13 hearts. So when I'm looking here, I know I've got 13 hearts. I know that 3 out of those 13 are heart face cards. Okay, so that's another issue of conditional probability. There are lots of different ways that you can ask this question. I could say something like, let's suppose you get a red card first. What's the probability then that I have a multiple of 3? So the multiples of 3 would be 3, 6, and 9. Well, I've got that in both reds. So 1, 2, 3, 4, 5, 6 out of 26 this time because I've got 26 red cards. So we can do all of that also. So I hope this helps, and we will take another look at this in a few minutes.